Okay, you are doing this one right here. Okay, so this is number 8. Okay? Labeling it number 8, then we're doing it in your notes. Okay, first thing that we're going to have to start doing today that we haven't done on all the other examples is you're going to need a diagram pretty much for everyone. Okay, so we're doing this one, start, if you have not already, and notes time. Ready? Okay, here we go. Okay, it says, a man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. At what rate is the tip of his shadow moving when he's 10 feet from the base of the light? So, picture time.
5 feet per second?
I know, he's running, let's be real. Pretty fast. Okay, so, he's in the splits. He could be in the splits.
What is this supposed to be?
That's the lamppost, obviously. Thank you. Been preparing my whole life for this. Okay, there's your lamppost. Okay, here's our guy.
Isn't he walking away from the light?
Do you see which way his feet are going? Okay.
Isn't he supposed to be like right next to it though?
We'll give him a hoodie, like a little beanie. He looks so happy. Okay, he's walking this way. Okay, he's so cute. I was going to give him a hoodie, but then I forgot. He's in a gang. He's in a gang. It's fine. Okay? Okay, there he is. Obviously, you have to draw it. Okay? Just kidding.
I'm copying like...
Okay, it's his hoodie. Come on, you scrubs. No, that's his hood. Come on, you never seen a hoodie before?
No.
Okay.
What's that long thing?
This is the light. This is the lamppost. Okay? Alright, so, then it says he's walking away from a light that's 15 feet above the ground. At what rate is the tip of his shadow moving? So let's draw his shadow. Here it is on the ground in front of him. Okay, there's his shadow. And what you should notice is that the tip of the shadow is going to be, really I should have drawn it further away. Okay, but it will make what shape? What? A triangle, not a sphere. Okay, so look. Here is your triangle. Now, I want you to locate in the picture a second similar triangle. The man, he is also a triangle with the same angle. Now, if you remember from geometry, right, all you need is a common angle and 2 proportional sides. So that is going to make these similar triangles. Now, let's label some stuff. Remember that constants get numbers, but variables get letters. So what is not changing? There are 2 things in the picture that get letters. Okay, the light is how tall? Okay, 15 feet. What else? Okay, the man is 6 feet tall. Okay, there he is. So those 2 things are not changing, but there are 2 things that are changing. How far away he is from the lamp. I'm going to call that M. And then S is going to be for his shadow. So M is from the man to the light post, and then S is from the shadow to where the guy is. Make sense? Okay, so let's do find, given, when, and equation. So what are we asked to find? What rate is the tip of his shadow? We're finding ds dt. Okay, given. They told us how fast he's walking. How fast is he walking? 5 feet per second. So dm dt is 5. Now, quick question. If he's walking away from the light, is his distance from the light increasing or decreasing? Increasing. So I need to put a positive 5 there, because he is going to be getting farther and farther away from the light. This side will be expanding. Okay, then it says when he's 10 feet from the base. What is that a measurement of? M. The man is 10 feet away. That makes it an M. Now, for my equation, you're going to have to use properties of similar triangles. Here's why. Pythagorean theorem is going to relate all three of these sides. I don't care about this side. Okay, I have two triangles that I need to relate to each other. What can you do with the sides of similar triangles? A ratio or a proportion. Okay, so I'm going to put sides of similar triangles are proportional. And what that means is that my equation is going to come from me creating a proportion or a ratio for the sides of those two triangles. Now, I don't want to put any letters on the bottom, so I'm going to choose to construct my proportion with S on top. So for my little orange triangle, it will be S over S. Or I said that wrong. S over 6. Got it? Equal to. Now remember, S is the base of the triangle, and S is the height of the little orange triangle. What is the entire base of the big purple triangle? M plus S, because I got to include this whole length. So my base over here is M plus S, the man's distance away plus his shadow, and then what is the height of the big purple triangle? 15. Now, you could have constructed this differently. I could take the derivative from here. Here's the problem. If I take the derivative at this point, I have all these fractions. So if I have a proportion, how could I eliminate the fractions? Cross multiply. Okay, but again, could you take the derivative at this point? Yeah, but you're going to have a bunch of fractions and you don't want that. So if I do 15 times S, that's 15S. And then if I do 6 times M plus S, that's going to be 6M plus 6S. Are we good with that so far? So I have 15S is 6M plus 6S. Okay, I'm ready to take the derivative, or I can try to simplify further. What additional simplification could make this easier? Yeah, you got S's on both sides, so I'm going to minus my 6 S's across, and then I won't end up with two separate ds dt's. I'll have all my S's together. So 15 take away 6 gives me 9S equal to 6M. Now we're ready to take the derivative. What's the derivative of 9S? 9 times ds dt. What's the derivative of 6M? 6 times dm dt. And then from there we're just plugging stuff in, right? We know how fast the man is moving. How fast is he going? Okay, so 9 ds dt equals 6 times 5. Well, 6 times 5 is 30, and then where's the 9 going to end up? On the bottom. Okay, now we are looking for units. This is the change in his shadow's length. What would that be measured in? Your primary unit is feet per second. What would his shadow be measured in? Feet per second. What if it was an area question? Feet squared. What if it was volume? Feet cubed. Good? Okay, next one that we're gonna do, I already did that one. No, we have to do one more. We're gonna do this one right here. Okay, water pours out of a conical tank. Good. Uh-huh. Okay, also too on this, something to think about. Does it make sense for my little sciencey people here? If he's walking away, should his shadow be getting longer or shorter? Longer, right? As you stand right under the sun, how big is your shadow? Right underneath you. Then as you walk away from the light, what's going to happen? Your shadow's going to stretch further and further. Okay, so if this came out to be positive, that tells me that his shadow is getting longer. Okay, and so in the context of the problem, that should make sense to you. The further I am away from the light, the longer my shadow is going to look on the ground. Okay? Alright, turn the page number 9. Says water pours out of a conical tank with a height of 10 and a radius of 4. Draw the tank. What shape is it? What does conical mean? Shaped like a cone. Very good. So imagine that it's your snow cone, okay, and it's all melting out of the bottom. Tragedy. Okay, there's your snow cone. Now, what does it tell me about the dimensions of the snow cone? Or the tank or whatever? What's the height?
What question is that?
This one?
Oh,
3 down? Okay, good. So my height is 10. And then what's my radius? 4. Okay, so it says water pours out of the tank with a height of 10 and the radius of 4 at a rate of 10 cubic feet per minute. If it's cubic feet, what did they just tell you? Okay, cubic, what does that mean? Volume. So dVdt is 10. Good? Wrong. What's wrong with it? Okay, so units are missing, but also it should be negative, because why? What's happening? It's pouring out of the tank, so I need a negative 10 here. Okay? Then from there it says, how fast is the water level changing? What would that be? How do you measure water level in the cone? Okay, think about its height. Okay, because think about why. If you want to know water level of like rain, you're not computing the full volume. You're just seeing how deep it is. Okay, so water level is height. So we're finding dH dt. Okay, then when, and then equation. What's my when? When it's 5 feet high, that means my height is 5. Now, how tall is the container? 10. So we need to remember that there's actually 2 different things going on here. You have the container, but then you have the water in the container. So think about when my water's here, we'll pretend like that's 5. Okay? But remember, it's not always 5. Is my radius here still 4?
No.
What happens to the cone as you drip down, down, down? The radius is shrinking. What else is shrinking? The height. So I need to apply letters here for the radius of the water, and then here for the height of the water. The container is not changing size at all, but the water in the container is. Now I want you to look for 2 similar triangles in your picture. Okay, I've already sort of drawn one of them. Where's the other one? Okay, if I go for the whole container, here to here, and then here to here. Do you see the 2 triangles? Okay, I have a little small one and I have a big one. Remember, what am I allowed to write when I have proportional triangles? A ratio or proportion. Okay? So keep in mind that I have 2 similar triangles. We'll come back to that in a second. Okay, what is my equation for volume of a cone?
2 pi r something.
Yeah, it's on the question though, so, right?
1/3 pi.
Silly geese.
I was thinking
The sphere.
yeah.
Okay, 1/3 pi r squared h. Now, if I take the derivative right now, what rule would that need? Because I got r's and h's. Product rule. We want to avoid it if we can. Go back to that proportion though. What do we know about r and h? What are they proportional to? R over h is equal to 4 over 10 because they're similar triangles. Can I create a substitution then
Yes.
for r? What is r going to be? 4/10 h.
Isn't it H5 though?
Now, is h always 5? No, then I have to treat it like a letter until after I've taken the derivative. That's a good question. In our moment, h is 5, but you can't plug in when's until after the derivative. So I can't put a 5 in for that right now, because it's not always 5. The water's draining out and the height is going down. Okay, so from here, is there any other way I could reduce that?
Yeah.
Okay, what is r going to be? 2 over 5h. And then we're taking that, dropping it in there. What was that? The reason why we're doing r over h is because if I take the derivative of this right now, I'm going to need product rule, and I'll end up with a dr dt that I don't know anything about that I can't plug in for. So if I sub r out and replace it with h stuff, not only do I not have to do a product rule, but dh dt is what I'm trying to find to begin with. Okay? So I'll have volume equals 1/3 pi. My r is going to be 2 over 5h squared times h. Now let's simplify that out because I don't want to take the derivative like that or I still have to do product rule. So what is 2/5 if I square it? Okay, so that'd be 4 over 25, right? And then my h is squared, but then I have another h. So how many h's are really in the equation? 2 here, 1 here. How many altogether? That's h cubed, right? So I have volume equals, what is 1 times 4 across the top? 4 pi over, what's 3 times 25 on the bottom? 75, and then h cubed. So again, what's the difference between these two equations? This one has multiple letters, it would have needed product rule. This one has only h's, I don't have to do product rule. That's why this one is better, even though really they're the same. Okay, from there we're taking the derivative. What's the derivative of v? dv dt. Other side, we're multiplying the 3 down. What's 3 times 4 in the front? 12 pi. 75 still on the bottom. I'm just going to ignore that. Huh? Okay, and then what's my new power on h cubed? Squared times dh dt. And then from there, now I know all the stuff I need. I can solve for dh dt. What is dv dt? We said 10. Negative 10. 12 pi over 75. Now I can plug in my when. When do I want the height? At a height of what? 5. Okay, well then what is 5 if I square it here? 25. So I have negative 10 equals 12 pi over 75 times 25. And what can these two things simplify to? 25 over 75. What is that the same as? 1/3. And what is 1/3 of 12? 4 pi. Yeah? So 25 out of 75, this gives me 1/3 when I reduce that. Then 1/3 of 12 gives me 4 pi. What's my last step? Divide, so I'll have negative 10 over 4 pi. Now, I can reduce it if I want to, but nobody cares, right? Either way. Now, what would my units be if this is a change in height? Feet per minute. And I'm just following the units in the problem there. If it was area, it would have been feet squared, volume, feet cubed. Make sense? Okay, so the next one that I want you to try while I pass out your progress reports, okay, this might be the last one, we'll see, is number 5. This one right here. And this is number 10. Okay, now listen guys, tomorrow we're going to add trig into this. So if you have questions, you got to ask them today. Okay, so really try this one on your own. What are the formulas for circumference and area? Area is pi r squared. And what is the formula for circumference? 2 pi r. Okay, so this is the third one from the bottom. You're trying it. You can work together. You can do it.
This is like the question on the homework, right?
There probably is one like this on the homework.
Because I think it's a good
Yeah.
question.
Yeah, sure. Okay, your progress report that I'm giving you, I don't care if you throw it away, but it does not include the corrections since the deadline's not up for it yet. Oh, yeah. When will I not be here this week? That's a better question. Yes. Hey, you're doing it, doing the things, doing it. Good, yes. You're gonna have to think outside the box on this one, that's why I'm letting you try
I
it.
don't like thinking outside the box. I like the box.
So if it's the change in circumference, it would be dc dt, right? So you do dc dt equals 2 pi over 5. That would be your given, because they're telling you what that one is.
What about the circumference? They told me the circumference.
Okay, then put that for your when. So your when is when circumference is
Oh.
10 pi or whatever. Okay, you're gonna have to think outside the box, but if anyone can do it, you can do it. You're a star. You're special. You're amazing. No matter what your progress reports say, I believe in
So when
you.
it says when the circumference is that, is it dc/dt or is it just c?
Can you say that one more time?
When the circumference is supposed to be 10 pi, is it supposed
So
to
that's your when.
is that dc/dt?
No,
or is
so
it
you
just
say
c?
circumference equals 10 pi. Because it's not saying the rate that it's changing, it's the actual circumference.
Oh, so when it's rate, it's dc/dt.
Yes, when it's a rate, it's a DDT. That's a good way to think about it. You need to get, I don't know, a magnifying glass. This school ain't got no money for big progress reports. So you get a baby one. They'll be on there whenever everyone's finished in the day.
I don't know the equation.
I put them up there.
Oh.
Which one do we use first? Is it
Good question. You guys have to try it. Work with yourselves. Okay, you're gonna have to think outside the box. Okay, I'll give you a hint. Okay, you're gonna have to take both of these derivatives. Okay, here's why. What are you looking for?
Area.
dAdt, and what is dAdt gonna need? A drdt. How are you gonna find drdt? They told you dcdt.
I
Does
don't
that
like
help
that.
you?
No, at all.
Come on, you guys, try it. Huh?
What is the,
It's not hard if you guys would just start writing.
what are we trying to find?
Take the derivative.
Is it dAdt or a?
Okay, I'm gonna set you up with the beginning.
Oh, wait. Wait, no,
we got it.
What are you finding? I'm not gonna do it, but what are you finding?
DRDT.
DADT. What? Okay, what is it asking for? How fast is the area? Yeah, if this is wrong, then you're just gonna be doing nothing. Okay, what are you given?
DCDT.
Circumference is increasing at a rate of, that's dCdt. Bless you. Okay, then what's your when?
C equals 10 pi.
Okay, now question, if circumference is 10 pi, could that be used to find the radius?
Yeah.
Yeah, so right, since,
How is it dAdt? Because it's 8 times. It's like,
so it says, how fast is the area increasing? That's a rate. It's not asking you for area. It's asking how fast the area is increasing. That's a rate.
no, because like sometimes I get confused of what to use, like dRdt.
So if it says how fast is the radius of the circle changing, that's dRdt. If it says how fast is the area changing, that's dAdt. If it says how fast is the water draining, how much water's in there is volume, that's dV. Does that make sense? So you have to kind of read the question all the way through.
Yes, sir.
2 pi dRdt. And then that dRdt you're going to be able to solve for, so which is the second part of the question. Yeah. So you're going to have, in this derivative, you'll have 2 pi r dRdt. So you know r, you just told me you found it, but you still need dRdt. That's where you're going to need this guy. Yes.
Why am I exempt from an AP Saturday? I wait.
They're in there for the different dates. So one of the AP Saturdays was, wait, she did one in November too. I haven't put November on here. I need to. Will you send me a message reminding me to put November Saturday on there? Because I didn't do it. Dina? Ms. Tucker? Jennifer's in 4th period. Chris? Mr. Here you go. Solomon's gone today? Brianna's gone today? Question? Where are you doing? You got twin? Get out your nose. I'm yelling at her.
Like the calculator?
So you're and that's your 2 pi dRdt. When you take the derivative of circumference, you get 2 pi dRdt. And then that's what you're solving.
She did the full time. She just.
And then you'll know what dRdt is, and then you can find. Okay, dCdt, that's great. Okay, when you divide by 2 pi on both sides, that's just different. You're not subtracting anything. You got a fifth? That's good. That's the right dRdt. Hold on, wait, you're finding the radius. Alright.
Yeah, I'm straight, bro.
Okay, now that's not C. That's dCdt.
I should just take it that. I don't know why I tried.
Okay, I'm coming. Come on, you guys, you can do it. Get him out.
How do you work on a
You actually work on it.
Yes.
Because Kathy hasn't worked.
I have to work with Kathy.
How's that bad thing where you get
I hate working with her.
You had to fill out tax form.
Oh, mine is 10,000. But if I was 1,000.
That's what I
You don't put that like.
No, come on.
That's why. That's what you can get in trouble.
I'm gonna get mine.
mean,
have sausage.
Okay, let's see what you have so far.
You live on native land.
Okay, if you have not already, take both derivatives.
You come from a little household.
Okay, what is the derivative of circumference? What's the derivative of that equation? Okay, make sure you change c to a dc dt. And then the derivative of 2 pi r is going to be 2 pi dr dt. Are we on the same page about that?
Yes.
Okay, now I'm going to put a line down the paper. I'm going to just do C stuff on the left, A stuff on the right. Okay, what's the derivative of my A equation for area? dA dt equals, my 2 comes down to the front, so it's 2 pi r to the 1. I'm not going to put the 1, but it goes down, and then, now this is the one that I want. This is the side I care about. Okay, I don't know r, I don't know dr dt, so I know I'm going to have to do some extra work. The first thing I notice is what was I given? And that's what I have right here. So I'm going to take my 2 pi fifths, sub it in, 2 pi fifths needs to equal 2 pi dr dt. Well then if I divide by 2 pi on both sides, okay, remember that's the same as multiplying by 1 over 2 pi. What's going to happen with my 2 pi's on the left side? And what is dr dt going to be equal to? 1 over 5. Okay, did anybody get there? Okay, good. Now, that's one of the things I need. What else do I need besides dr dt?
R.
Regular r. They didn't tell me a regular r, but what did they tell me instead? Circumference is 10 pi. So question, if circumference, I'm going to just do this up at the top. If circumference is 10 pi, what is the circumference formula? If 2 pi r is 10 pi, then what's r? 5. It's just like when they give you like 2 sides of the triangle, but you have to go back and find the third one. It's the same kind of thing. They're telling you something you don't really need, but you can use it to find what you do need. Okay? So then r is 5. And now from there I can plug into here. So I'll have 2 pi, my r is a 5, my dr dt is a 1 over 5. What's going to happen with the 5 and the 5th? Voop, voop, 2 pi. Units, if this is dA dt? Inch squared per minute. Make sense? It's a box in a box. Okay. So, tomorrow we're moving on to trig. We have about 5 minutes. Do you want to do a homework question?
Yes.
Okay, pull it out.
The ones you haven't been on the thing.
I didn't do any of them on the video. Oh, I didn't send out answers to homework 10.
You're Willie though?
Maybe I will. Price work?
After on Monday of the week before the break.
Let's do number 6.
Hey, hold up.
Just shoot me a message, Nikki. 6?
I have one.
Oh, good question. This is the one I was hoping you would pick. Okay,
You're welcome.
we have 5 minutes, so let's see what we can do. Number 6.
Sarah, you 7, don't you 7.
Okay, it says, suppose a roll of paper towels is 20 centimeters tall and the paper towels are being unrolled so that the radius is changing at a rate of 2 centimeters per second. So, here we go. Roll of paper towels. Okay, I'm unraveling them. This way. No, I don't care if you draw the picture or not. What is changing? What is staying the same?
Stay the same as the height.
The height is the same. What's the height for a roll of paper towels, it
8
says?
centimeters.
20. So this distance is 20. I'm not going to give it a letter H because it's not changing. Okay, but what is changing as I unroll them? the radius. So I have to give that a letter. I'm going to call it R. Good? Okay, find given when equation. In case you didn't hear, I don't care if you draw a picture. That's totally up to you. Okay, it says the towel is 20 centimeters tall, not a variable. Then it says it's being pulled so that the radius is changing at a rate of 2. What did they give me? DRDT. Is it positive 2? Why negative? Because the paper towel roll is going to shrink as I unroll it, right? Okay, then it says find the rate of change of the lateral surface area. That's DSDT. You could also use A if you want to make it surface area, or you can use S for surface area. It doesn't matter. Okay, then from there it says at the instant when the radius is 4. Now get out your white sheet. What is the surface area for paper towels? Lateral only. Oh, they did pi RH, 2 pi RH, thank you. And then you're just taking the derivative. Now, if I take the derivative right now, R and H, whenever you have a letter mix, you're doing product rule. But which one's not really a variable? H, height. What's height? Then I can plug that in here before I take the derivative. S is really 2 pi R times 20, which is 40 pi R. What's the derivative of that going to be?
40 pi DRDT.
DSDT equals 40 pi DRDT. And then what's DRDT?
Negative 2.
-2. Plug it in. What's DSDT?
Negative 80.
-80 pi. Now that's surface area. So what would my units be? Centimeters squared per second.
Is that it?
Yep.
Wow. Yeah.
Okay, but if you forget that height is a constant, you end up, it doesn't work. So you have to remember, if one of the constants is fixed, you can plug that in before you take the derivative. Okay? Alright, test corrections after school. And drop forms. If you're planning on dropping, I have to sign it, so you have to tell me. I'll find out. What?
I ain't in that class.
There's no other class, you just would have a hole in your schedule. So you'd have either like teacher aid, they could put you in like a Rams University class to torture you, but they can't make, you can't go backwards into a math class, you're at the highest one already. So you can't go like backwards to pre-cal. Yes, ma'am.
And I'm in track.
So I'm staying after for a little bit on Friday. You won't have time to do both. You would maybe have time to do one. But if you do one, then you can do the other one next week. The problem is you have a CBA next week, and so you're already going to have CBA corrections going on. You can't come today or tomorrow after school, though?
I mean, if you want to sign off on my
She's
absence
a cross
hours
country.
tomorrow.
Are they for my class? What are they for?
Snap that home.
Someone said that they have to be in the class you've got the absences in. They don't? Okay, then I'm happy to sign off for it. I mean, when you come in and actually do it, right? Absolutely. You're welcome.
Do you want me to come?
Yes. And actually, the snacks and stuff, thank you, ma'am, are all in my car still.
Okay.
So I may have you 8th go down and just grab them out of my car. And then get, like, the stuff ready. That'd be awesome.
I'll see you later, Phil.
Bye, fam.
Oh shoot, you snap.
No snap at the end? I feel like that's cool to do that.
No, I can't snap. That's why I don't snap.
Oh.
I'm like,
What kind of person can't... You get a little snap. It's small. Small but mighty.
well,
Oh, Miss Jordan's absence from 2 weeks ago. Wednesday.
Yes. Okay, it was Wednesday, the first day of the sub. What?
Yeah.
Okay, I'm looking it up right now.
Dude,